All right, hello everybody. We're going to talk about JavaScript applicatives. By the end of this lesson, you should be able to process arrays using map, filter, and reduce, and process objects using map, filter, and reduce. We've been doing a lot of for in and for of lately, and these are good skills to have. But that map, filter, and reduce life that we came to love so much in Mod 1, guess what? We can do the same shit in DribbleScript. So, all right, let's take a look at this first one. Processing arrays using, let's say, map.
Do you call JavaScript DribbleScript?
Yes.
Okay. You said that earlier this morning, and I thought you were referring to something else.
Correct. Nope, calling it DribbleScript because I can't think of a clever reason. All right, so let's start with map. What's map do?
Takes returns that are arrays that equal size what you're calling them.
Yep, same size to same size, right? Why would we do such a thing? When do we use map?
To apply certain functions like adding two numbers or like alphabetical.
You want to train.
Colin, what you got?
If you have like an array of arrays, but you only want like a specific element, you can just create a new one with only that.
Yeah, sure. So like if you had Colin saying that if we have an array of arrays and all I want is the first thing in each of those arrays, so 1 and 3, if I map over this outer array, it has two members. If I want two things back, I could map over that to turn it into something like 1, 3. Okay? Give me some more examples of when we use map.
Do you want to transform some data?
Transforming, great example. So I have a list. I have the word cat. And I want to turn it into the word cat in an array. I want to uppercase everything that was in there. That would be a thing we could do. The most common thing that I see with map is arrays of objects, and you want a particular thing back. So I've got an object with an ID and a name. These are dogs. If I want to turn this list of two dogs into a list of two dog names, that's probably 80% of the time you're using map. You're probably doing something like that. How would I do that in this case? I saw some of you mapping your little hearts out yesterday. Ben.
Dot map.
Okay.
Dot map, and then parentheses.
Mm-hmm.
We call that dot, and then arrow key. Dot.
Dot? Oh, dog.
Dot name.
That's exactly what we do. This works a lot like blocks did in Ruby. They're actually significantly more powerful because they're full on functions. Blocks are pretty much limited in what they can do in Ruby. Functions are functions. They're powerful. One of the most powerful things that we have. And that is a shorthand for them. And we're going to use that a lot. So let's talk more about fat arrows. So fat arrows are another syntax for functions. So we can write a function like function add takes in number and an other number. We give it a curly brace, and we return number plus other number. Okay, that's a function. We did that in the pre-work. We've seen this all over the place. Now this exact same thing we can write as number, other number, fat arrow, number plus other number. Those two things are equivalent. This and this do the exact same thing. If it only has one argument to it, we don't even need the parentheses. We can do something like x times 2. These are the parameters for the function. Fat arrow takes the place of the function keyword. We don't need that anymore. And if we're doing it all on one line, we don't need to return. You don't need to use the return keyword. It's assumed that this one line here is the thing that you're returning. If we have more than one parameter, gotta wrap it in parentheses, otherwise works the same way. Another syntax quirk of this. Let's say it's not just one line. And let's say that it doesn't have any arguments, parameters. Doesn't have any parameters, then we still have to do parentheses, but we just don't put anything in them. And if we want to put this on more than one line, we use curly braces, we can do whatever, and then we have to use the return keyword again. That also is valid syntax. That, and that, and that, and that. All different ways to write functions. Depends on the context, because there are some different quirks to these. The first one, we call that a function declaration. And the cool thing about them is that they hoist. Hoist means that we can put them absolutely anywhere in the file and use them absolutely anywhere in the file. Doesn't matter what order they were declared in. That's pretty cool. The other three, at least for this mod, you're more likely to see, and kind of the next one, you're more likely to see in things like map, filter, and reduce. We have a lot of methods like that that take functions as arguments. It's pretty common to see the fat arrow syntax with those. If you're only doing one thing, and it's something like getting the name back, doing it in one line makes a lot of sense. If you're doing something a little bit more involved than that, it makes sense to put it on more than one line, but now you need to use the curlies and use the return keyword. Cool. Let's see what this looks like in code.
So, you wouldn't want to put something like, if you don't want other parts of your code to have access to it, maybe?
because the reason you would not want to hoist something is there are some that think that hoisting is confusing and that you shouldn't be able to use something before you've declared it. And that's the case in a lot of languages. I say, grow up, crybaby, hoisting rules. Learn how it works.
Sweet.
More sensitive, whatever.
Let's call this applicatives. Make an app.js file. All right, so if I have students and student has an ID and a name, all right, so there's my array of objects. I want to get everybody's name from this. What I want you to do is see if you can write this out. You can do this in your console. So like you open up a browser, put it on absolutely any page, and do Option Command I. Go over to the console, and we can just do whatever here. Const A equals 2, A times 2 is 4. So we can play around with that. You can also use a tool like Replit. So if we go over here, oops. Leave page, leave page. And I don't want to continue coding. I want to see my REPLs. I want to make a new one. Why is it not
Can you make a new one in JavaScript or Node.js?
doesn't matter for this.
Okay.
New. Why am I having such a hard time with this? Give me another one, asshole. Yeah, it's public. All right. So we can do stuff in here, run it, see the result. Pretty cool. Or the other way you can do it, if you want to use your text editor, that's what I'm going to do. We can just make a file, give it a JS extension, and if I want to, for example, log the students, run node app.js on the command line, it'll print out whatever from the file. All these options to follow along. So what I want you to do, write out these students and map over them to get only their names. Okay. If I want all these students' names, students.map, student. Also, that pattern, don't try to get clever with it. Your arrays are generally plural. When you're mapping over it, that should be the singular version of it. Don't have to come up with a clever, different name for it or something. Plural, singular. Super common. All right, so I want their names. That's what I get back from that. And so if I console log that, cool, Priscilla, Damon, Andrew Gage. Now, let's see some other ways we could have written that. That function that takes in a student and returns student.name could have also made that a declared function called getName that takes in a student and returns student.name. That function does the exact same thing. And check this shit out. If map takes in a function definition, why? That's a function definition. So if I do that, Priscilla, Damon, Andrew Gage.
What if the function get name take in students, like that array? Plural students?
What do you mean?
Like the function get name, you just an argument.
I'm so glad you asked me that. The reason these are called applicatives is I have this array of these things. The function that I'm passing in, like getName, gets applied to that. And then that gets applied to that. Then that gets applied to that. And then the result is a new array with the transformation, with that function having been applied to each thing on there. Pretty dope. Cool. So these two things are equivalent. We could have also written that if I run this, same thing 3 times.
Because if you put in the curly braces, like, yeah, if you didn't have those curly braces there, you wouldn't be able to use return because it would just be
Fact. All 3 of these are the same. And since you'll see somebody do it at some point, I've also written that in line like that. And if I run that, by Jove, same thing 4 times. One thing I want to point out, this getName, that's this function here. You'll notice that I didn't do that or that.
Does it just naturally pass in the argument? Like,
Map takes one argument. It's a method with one parameter to it, and it's a function definition. getName is a function definition. If I do that, what's getName now? What's this equal to?
a function call.
It's a function call. It's equal to the return value. And so since we didn't pass anything in, it's going to return, well, an error for one, but student is undefined.
I noticed that. I did that first and I was like, what the hell? I was like, oh, okay, interesting.
Function definition. We talked about this yesterday. It's a data type, just like Boolean, strings, anything else. And lots of stuff in JavaScript takes in function definitions as arguments. And here's 4 different ways that we can do that. Questions?
So in Ruby, you have to give it a block.
Correct.
Is our equivalent of a block just a function?
Yes.
definition?
So all those things in Ruby take in blocks because Ruby doesn't have standalone functions like this. Everything is a part of an object. So even when you're kind of doing it out in the middle of nowhere, like we're doing it here, you're still inside of a class called main and all these things. And so blocks serve a very similar purpose. There's also 2 things in Ruby called lambdas and procs that are also kind of in this ballpark. But this is a fundamentally functional programming idea, and Ruby is fundamentally an object-oriented language. Those 2 things don't really go together. But since this is such a fucking useful thing, Ruby hacked in some ways to do applicate programming. But yeah, works just like a block does. Neat, what else?
For the 4th example,
Mhm.
students definitely have function student. You're declaring a new function in there and that's taking it as its argument.
Correct. I'm declaring it in line. You don't even need to give it a name. It's called an anonymous function.
Oh, I've heard that.
There you go. That's what it looks like. Fun story. You can actually, there's such a thing called named anonymous functions. We can also do that. It's still technically an anonymous function because you don't save it anywhere. You can't reuse it anywhere but right here. But there is an advantage to doing this. You get better error messages. Because otherwise it'll go an anonymous function on line 21 through an error. But you should know that almost nobody does that. Not for any good reason. Just these things simply aren't done, old boy. Other questions about this? Cool. So next. Wipe. I want you, yes you, to add these to your students. We're gonna do ages, and I don't want to know your actual ages. I don't give a shit. So make some up. Make sure you get your commas right. All right, so I want you to use filter to give me all the students who are under 10. Go.
I did not get that first.
Not quite as depth. Evaluation.
Dad jokes.
So things like
Dad joke contest. Younger than 10.
No problem, thank you.
You almost had it.
Yep. Yes.
Yeah. Wow, student age, just compare it to 10.
I saw that. Beautiful, man.
Easy. Oh, it's because
Saw a couple you go above and beyond. No, but that's what the rest of them did. We can figure out how to do that before I demonstrate it. That's bonus brownie points. All right, so the students under 10, students.filter student, and then with map, we're applying it to each one and returning the result. Filter, a little bit different. What's filter expecting? Each of those things we're applying, what are we expecting it to return? True or false, or really truthy or falsy. But if it's truthy, it keeps it. If it's falsy, gets rid of it. So we can say student.age is less than 10. That is something that will evaluate to true or false. And if we run it, we get 2 people back. Now, the baller bonus points thing that I saw a couple of you do, is now you can map over that and get their names. And if we do that, Priscilla and Damon. Pretty sick. And let's look at some other ways we could do that. As soon as you start chaining this stuff together, it gets a lot harder to read. So it's really common to do something like that.
Oh.
Breaks it up real nice.
That's nice.
And, oh baby, to quote my dad. Let's say I do age less than 10, takes in a student and returns student.age less than 10, and a function called getName that takes in a student and returns student.name. Now, hey, you want a function definition? Get your function definition.
Oh, the combo. Crazy combo.
Priscilla and Damon.
Got that footwork. The JS footwork.
Here's the thing I really like about this. This reads like a little story.
There you go.
Take the students, filter down to the ones with age less than 10, and then get their names. Pretty cool.
Spicy.
That's filtering.
Is that like the cleaner way to do it, or more like readable way pretty much?
I usually don't start there. I usually start by writing them all inline,
Oh,
and then I try to pull them out into these functions
Ah,
before I move on.
makes sense.
In JavaScript,
Mhm.
you have an equivalent to, like, when you would do, what was it, be select in Ruby, you used to do .map, ampersand, name.
Not really. You're kind of looking at it. The shorthand with the fat arrow, that is the equivalent to that. There's also a library called Lodash. And this has a bunch of methods in it. This is kind of like the missing library for JavaScript. We can do things like flatten. I guess that's actually built into JavaScript. We can take an array of arrays and then bring that one level down.
I tried to use flat earlier on REPL, and it was like, that's not a function. It was kind of weird.
Right. So difference, this lets us do set math So like you can subtract an array from array or add arrays or those kinds of things. So this has a way to do something a little bit more like that cool Ruby shorthand. Otherwise, the best we're getting is fat arrows. Other questions about filter? Neat. Last thing. Let's say, I want the average age of everybody in this array. Average age of everyone in the array. Talk me through this one. Think to yourself for a sec how you would go about approaching this. Average age for these students. All right, I'm going to call on somebody. Arlene, get me started.
So we start just by like getting an array of their ages, kind of like we did with the names, students.maps.
Sure. So I'm going to map over the students, and for each student, what am I getting?
Student.age.
Love it. Okay, so at this point, I've taken my array of students, and now I have an array of numbers. Nice. Okay, what next, Arlene?
So we can add that up.
How do we add that up? Someone help Arlene out. Reduce.
So we have reduced it.
Yes. So syntax is a little bit different though. Reduce takes two arguments. The first one is the function that we're applying on each one. The second argument is what do we start with? So I'm going to take some function, and then I need something to initialize it with. This is your base case. There's nothing in the array. What do we start with? With numbers, we usually say 0. All right, this function that you pass in takes 2 arguments. Now, this is where this starts like getting a little bit brain hurty. Reduce takes 2 arguments. The first one is a function which takes 2 arguments. Traditionally, we call that the accumulator and the item. I would recommend naming them a little bit better than that. Just specific. We're going to say this is the current age. This is the one we're dealing with next in the array. And we're going to say this is the cumulative age. The way this works, this is not nearly as complicated as it looks. This is the first value of cumulative age. This is the first element in the array. Whatever we return out of this becomes the next value for cumulative age. When we get all the way through it, whatever we return ends up being what that evaluates to. So all I need to do is return cumulative age, what? plus current age. So there's 4 things in here. This is 0. This is 5. We return 0 plus 5. Cumulative age is 5. Next one is 1. 5 and 1. That's 6. Cumulative age is now 6. Next one is 10. So we have 6 and 10. Return 16. Cumulative age is now 16. That's 16. That's 20. 16 plus 20, 36. But now we're through this, so that reduced down to 36. What's cool about this, and this is, we talked about this a little bit with some of the problems you were working on yesterday, is this doesn't have to be just numbers. We can do this with arrays. We can do this with objects. So you could be gradually building an object 1 key at a time. And then you just return that object, and you've gradually built out keys and values on it. Dope. I think students tend to get intimidated by reduce because it's conceptually a lot more complicated than map and filter. But that's all it is. You can draw arrows between these things. Cool. All right, so we've reduced this down. We have the total age at this point, 36. What now? How do I get the average age?
Divided by how many students there are.
How do I find out how many students there are?
Students dot length.
Students.length. If I run that, 9.
Is there a round method in JS as well?
We don't have to, but yes.
Okay, just curious.
Math.ceiling and math.floor.
Oh yeah.
Oh yeah.
I love those.
Math.ceiling, yo!
Straight from the roof.
Cool, what else?
Just to clarify, that 0, that's right before you did the divided by student dot
Mhm.
length, that's going to be like the return value for the reduce?
No.
What is that?
That's the initial value for cumulative age. Whatever the accumulator is, we're saying we want it to start with that.
Right. So if you did like a 5 there,
Mhm.
that would like add on to.
Correct. So if we're offsetting this all by 5, we expect that to be 41. Oops. Oh, the average age went up. There we go.
So, that'll always be an integer.
No, because that can also, it depends on what we're trying to do. In this case, we're adding up numbers. So our base case on that is an empty number. If we were building an object, then that would probably start as an empty object that we can set keys on. If it were an array, we'd start with an empty array. If it were a string, we can gradually build a string. That would probably start as an empty string.
It just seems like it's doing the opposite of reducing it, right? Because it's building it.
Yes, but it's taking this, which was an array of ages, and reducing it down to 1 number.
Okay.
So it's not lowering, it's consolidating. Other questions about reduce?
Could we write like building an object?
Yeah, absolutely. So I want to build an object where the keys are student names and the values are their ages. And so the thing that I want to get out of this will look like
You're smart.
So I'm trying to take that array of students and reduce it down to an object that looks like this. What do I do? Volunteer. Damon, get me started.
So we probably want to. We probably want to get all the students out of the array, right? Or no, not even. Just get all their names and ages. Can you do that in one map? Or because if I want to get both their name and their age.
I'll give you a hint. There's only one thing that we need to do.
Can we just reduce? Okay.
All right, so sum function, and Priscilla, what's the initial value going to be?
The
Empty
empty object.
object. So this is going to be the initial value of our accumulator, and we're going to call it student ages. And then, can somebody give me a good name for each individual item? Current student. So, first time this goes, student ages is going to be this empty object. This is going to be the Priscilla object. So what I need to do is set student ages at current student dot name equals current student dot age. That's it.
You missed a S
Oops.
in student ages.
You need it on the end of age.
Yeah, and age is the student age. Yeah. Here you go.
Oops. That's that property Damon of oh, I also have to return
Oh.
student ages. Cool. I reduced a collection into one thing. Now the part about this that's counterintuitive is that one thing can be one object, one array, one string. That still counts as one thing. That is so fucking cool. Reduce is so powerful that we can recreate map with it. We can recreate filter with it. We can do find with reduce. Reduce is the Swiss Army knife. There's pretty much nothing you can't do with it.
You can also probably build nested objects like that, right?
Indeed.
That's cool.
Other questions about reduce?
Could you just kind of like run me through this, the reduce right there, this whole thing?
I'll do you one better. Somebody volunteer to come up to the screen and walk through what's happening in that reduce. Someone who isn't Damon. Damon gets out. Put yourself at risk. Take a shot.
Thank you.
You'll learn more, promise. Nobody wants to learn more? Fuck.
Would you like my explain
Andrew, 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 Andrew. All right. How does this reduce work?
Alright, so this is all the ages given. Then this is just the current student we're dealing with. Then this is student ages of the current student dot name, so it's selecting it by name equals current student dot age. we pretty much return all the ages total, which is the empty object that we built right here.
I see. So like current student age is like going into student ages.
Yeah, pretty much, exactly.
With no,
And student ages is what's being built right here.
And you're treating
Return it.
key as the name of the current student.
Exactly, and that's the value right there.
Indeed. Thank you very much. Another way to think of this. The first time, in the first iteration of that, the thing that we're going to get back is that. Then we get Damon added to it, and then Andrew, and then Gage. We're gradually building that. Pretty fucking cool. Other questions about reduce? All right, so we have processed arrays using map, filter, and reduce. Let's talk real quick about how we do these with objects. You guys have had a lot of problems in the last 2 days where you have to do some kind of array magic with an object. Doesn't work. Ruby, we can do the same enumerables on any kind of collection, including arrays and objects.
It's too easy for me.
Not so easy with Dribble script. There is, however, 2 magic methods that make this a little bit easier. So if I have something like that, I can neither map nor filter nor reduce this object. However, I can pass that into object, capital O, dot keys, and get an array of the keys. I can also use object dot values. If I pass that into it, I get an array of the values. And if I, once these are arrays, map, filter, reduce. That's the hot shit. Let's prove it.
But then, doesn't that like separate it from the values when you only have the keys, you don't need
Yes,
values?
correct. There is something that'll give you both of them, entries.
Look at Axe.
It acts predictably.
Yeah.
So, let's see. So this will give you an array of arrays. Actually, hang on, let's just do it. It gives you an array of arrays that the first thing is the key and the second thing is the value, just over and over again. So if you did need those together, that's a way you could do that. So we'll say this is studs. So if I log studs, there they are. If I do object.keys studs, I should just get your names. Done. If I do object.values studs, I get an array of the values. And then if I do object.entries studs, I get key value, key value, key value, key value. But the fucking cool thing, it's the same number of things. And that means I could do something like map them. So if I mapped that, and I wanted to recreate something more like what I started with, I could say, all right, student is an array. 0 index is the key, 1 index is the value. So I could say, I want to return an object where the name is student at 0 and the age is student at 1. And let's see what happens. Shoot. So I gotta scooch those up. Looks a whole lot like what I started with.
Fucking nuts. Array of objects.
Is fucking nuts. So fear not, you don't actually have to write that many for ins and for ofs.
Yeah, I was scared. I wrote so many nested upon nested.
Good, made you a better programmer.
Yeah.
But I tend to prefer applicatives whenever I can. But keep in mind, it's a little bit less efficient because you usually have to coerce stuff around. You usually have to go through a list more than once. So the for loops probably going to be more performant than these. But I think these are a lot easier to read and they tend to be more concise. And if something is more concise, there's less place for a bug to hide. Cool. Questions?
Can you explain object.entries again?
Absolutely. So if object.keys gave us this and object.values gave us this, object.entries kind of combines them and gives us, let's see, about teal. That as an array, that as an array, that as an array, as an array. So it makes an array of little 2-member arrays. So the first thing's the key, second thing's the value. More questions?
I guess a lot of places are actually writing vanilla JavaScript, but let's assume they were for some reason. Would they prefer you to use for loops, or they prefer you to use like entries and stuff?
Depends on the shop, but I'll always use an applicative unless I have a performance reason not to. They're just so much easier to read, so much easier to work with, so much harder to fuck up. But I'll start there, and if there's something that's like, oh, this is just too slow, because they do happen to be the slowest things in JavaScript, then I think it's a lot easier to go, okay, well, I'm going to wrap this in a function, and the function definition is going to stay the same, the thing it returns is going to stay the same, but I'm going to rework it to be more performant. In which case, you're probably more likely to use something like a while loop. That's like the most performant thing. But for in and for of are both like pretty fucking fast. I'll also say that has never happened in my entire career. That I've had like need to like strip this piece out and make it more performant. So that's the kind of work that I do. I'm a what they call a prototyping engineer, not a performance engineer. What else? Yeah.
I'm so confused how you use map
Mm-hmm.
after the object.entries to turn it into an object.
Excellent. So I object.entries this, and so I got, like in this case, an array of 3 things. I can call map on an array. When I turn these 3 arrays into 3 objects, that's a hint that you need a map. It's going from 3 arrays to 3 objects. It's just a transformation. So I go, how can I turn this into an array, or into an object? And it starts by making an object, choosing what I want to call this, choosing what I want to call that, and then assigning them. And so it ends up looking like that.
You also put the curly brackets after the return, so is that what is essentially making it an object?
Yeah, so let me rewrite this as like maybe like that. All right, Arena, explain to me how that map works now.
Okay, so like you're mapping over every student in students.
Yep.
And you're creating a new object, and then for each, like at index 0 of student, you're creating a name. Name is the key,
Mhm.
student at index 0 is the value of that.
Yes.
Of that original array.
Correct.
Or for each array in students.
So student at 0
Yeah.
is Priscilla, because that's the key. Student at 1 is 5, because that's the value. Key, value, key, value. Ordinarily, the indexes are kind of arbitrary. They're not in this case. We use object.entries. Index 0 is what the key was. Index 1 is what the value was. And so then you can build a completely new data structure with just those as placeholders. You can name them whatever you want. All right, we're gonna try again.
So you object.entries is turning that object into an array of
Mhm.
arrays.
Yes, correct.
And you're mapping over each array. And then creating a new object that has the key of name of the old key at index 0
Mhm.
in the array.
Yes.
And then for age it's index 1.
Well done, Arena. Okay. Lingering questions about how we apply these things to objects. All right, let's take a quick break, and then we're going to do a radical gear shift and go back to APIs.